This is a solution video for the parking lot problem from the optimization extension questions. So the total area of the parking lot is 240,000 square feet. Okay, and we're trying to install a fence. The cost of the fence for the front of the lot is $10 per foot, and the other three sides is only $5 per foot. Determine the dimensions, which will result in a minimum total cost of the fence. Okay, so let's set up our diagram. Okay, so I don't know my dimensions, so we'll call one X and one Y. I do know my area is 240,000 square feet. Okay. So that's something I know. Area, which would be X times Y. Okay, so that means 240,000 is equal to X times Y. Okay, I imagine this is what I'm going to have to isolate at some point. So let's do 24,000 over X equals Y, because I'm sure we'll need that at some point in an optimization problem. Okay, what we're trying to minimize is the cost. Okay, so C is equal to, okay, it said that the front, so let's call this the front of the lot. Okay, it costs $10 for that, and everything else is $5 per foot. Okay, so as I go around the lot, okay, that first stretch would be $10 times whatever X is, plus $5 times Y, plus $5 times X at the back, and then plus another 5 times how long the Y at the bottom is. Okay. So collecting my like terms there, that means I'm going to have 15X plus 10Y. Okay, this is what I want to optimize. Okay, and this is why I isolated my other equation, because I need to get it all in terms of X or Y. So 15X plus 10 times 240,000 over X. So tidying that up a little bit, I have 15X plus 2.4 million over X. Okay, so I have my constant function entirely in terms of X. Now it's time to take my derivative and see what happens. So C prime, derivative of 15X is 15. Okay, this is really the same thing on the side here, right? That is 2.4 million, X to the negative 1. So I'll bring down to negative 1, and it'll become power negative 2, so that's over X squared. Okay, I need to solve this for X. I need to set my derivative equal to 0 and solve. Okay, so because it's negative, I'm going to move my term with the X squared to the other side. I will be so good at writing zeros by the time I am done this example. So two things, I can bring the X squared up here and I can bring the 15 down to divide. So I'll have X squared over here, okay, and then 2.4 million divided by 15 is 160,000. Okay, take the square root and we get 400 is equal to X. Okay. So on the side here, that means Y would be equal to 240,000 divided by 400. So let's see, divide that by 4, you have 600 for Y. Okay, so it looks like the dimension should be 400 by 600. Okay, let's take a moment to verify that this is actually a minimum. So again, I'm going to go to my second derivative test to verify. So C double prime, my constant is gone. Okay, and I have 0. The next derivative of this, we bring down another negative. So it's going to be plus 2.4 million times 2 is 48. 4.8 million over x cubed. Okay, well, when I plug in 400, this is going to be positive for sure, as is this. Okay, so C double prime of 400 is positive. Okay, that means that 400 is a minimum. Okay, because again, that means because it's positive, that means I'm concave up. So I must have a minimum in that region. Okay, so therefore the dimensions, they give me the best area, or sorry, the cheapest fence are 400 by 600. Thank you for watching.